go out, I'm busy. I'm in our shop, anything, talk to me, Diani. There were yes, busy with a nice set.
As long as we want.
And can use Android.
Yeah,
No
I can't
blame
let it
for
go.
Android.
A2. A2, yeah. This is A1. A2. Yeah. Okay. Let me explain. This is a power circuit, ne? Yeah, you can take me video, no problem. As long as, yeah, I don't.
Thank you.
This is a power circuit, this is a control circuit. And if you check, we call it DOL. Ne? DOL stands for direct online. Ne? Then let's check. Let me start from here. Here is a circuit breaker of a three-phase. Line 1, line 2, line 3. And when you see if the toggle is like this, that means the circuit breaker is open, it's not closed. When you push it, this is going to close there, this close there, this close there. Then that means there will be a power that is flowing from that side to the contactor. Then here is the circuit breaker that I'm talking about. It's just like this. But when you take it like this, you take the toggle upwards, then that means there will be a continuation from line 1, line 2, up to line 1, line 2, line 3 out. You got it? It's this part. Then from there, it means when you see this, this is a contactor. Ne? Yes. Remember what's a contactor? Is an electromagnetic switch that control a larger current. Ne? It's a larger current that we're going to deal with it. Even the contactor itself, here is a contactor. It has line 1, line 2, line 3. Then when you come with a power supply, you connect it to line 1, line 2, line 3. Ne? That means when you switch it on, then there will be a power up to here. So you have to connect a wire from here to line 1 of the contactor, a wire from line 2 to line 2 of the contactor, a wire from line 3 to line 3 of the contactor in. This is how in the drawing looks like. From line 1, line 2, line 3 out, it goes to line 1 in of the contactor, line 1 of line 2 in of the contactor, line 3 in of the contactor. Now, then and our contactor also it has an overload. Now, it has inlet and outlet. Line 1 out, it goes to overload. Line 1 in of the overload. But that one is automatically, it's already connected. You can see that one, again, with the overload. So that means if it's already connected, we can see we have an overload. Then the overload, the line 1 out of the overload, it's going to a motor. Line 1, 2 of the overload going to a motor. Line 3 out of the overload goes to a motor. But I'll show you the connection of the motor, but this is just a motor there. Then it's an outlet of, they call it the T. T1, T2, T3. It goes to a motor. Do you understand that? Yes. Then now, yes, from a line 1 out, supply a circuit breaker out. Our circuit breaker out is this one, CB. Then we are here. This is our circuit breaker out. We've got 2 circuit breakers. You can use 1 or 2, but if you want to use it consecutively, let us prefer this is a line 1 out. Then that means there will be a wire from this side to line 1 out. Is this part. Line 1 out from a 3-phase circuit breaker to support what? A circuit breaker out. From a circuit breaker out, it goes to what? 95 and 96. And 95 and 96, you can see is what? Is a normal close. A normally close is the NC stands for normally close, NO stands for normally open. Then it means line 1 out is here. From circuit breaker out, it will go to the contactor that you supplied from a 3-phase circuit breaker. Which contactor is this one? And then here, what are we looking for? You're looking for the overload. The value of what? 95 and 96, which is normally open. Then there's it. It's 95 and 96. And this 95 and 96, they beep together because it's normally closed. There's a continuation. So what is the purpose of that, if you remember very well? If it has exceeded its predetermined value, what will happen? The overload, it will trip. How it trips? The 95 and 96 become normal open, which is 97 and 98. Let's check the motor, if you can see the motor here. This motor, it has a nameplate. You see, this is a nameplate. They wrote all the information that is needed for the motor. Then on a nameplate, they wrote the current. Let's check the current here. Here the current, let's check the current is what? The voltage. Let's take the current here is 1 ampere. Ne? Then here the current flowing towards the motor, then is more than 1 ampere. What will happen? The overload itself, it will automatically switch off or trip. Because it has exceeded its predetermined value. Then from 95, 96, it goes to what? If you check, to E1 and E2, each and every component inlet and outlet, to emergency 1 and emergency 2. And what is the emergency stop button? Is this one, with the mushroom, the big head like mine, like Nigerian, you see? This one. In and out, you got it. Then from there, here go stop. This is a stop button. And we know the stop in the color coding is red. Yes. From there to stop, in and outlet goes to what? To start. Do you understand? And on the start, we have the start 1, and the start 1, and start 2. And on this side, it goes with 13 and 14. Some they can use 3 and 4, but normally it's 13 and 14. And this 13 and 14 is what? It's 13 and 14 of the same contactor, this contactor. You understand? It's 13 and 14. And if you can check there, it is open. It's open now. It's normally open. Then when you press the start, when you activate the start, that means it's going to close here. This push close here, and then now it's energizing what? A contactor. This is a contactor. A1, then go with A2. A2 to what? Line 2 or line 3. But this one, it depends on the value of this contactor. If a contactor, let me write it here. If contactor is 230 voltage, develop the contactor, we check it here. 400, what, 4, 230, I can see 400.
Yes.
Now, if a contactor is 230 voltage, that means line 2 A2 is equal to line 2. A2 is equal to line 2. That means from A2, we're going to connect it to line 2 or line 2 that side, in order for our motor to run. But if the contactor is 400 volt, that means A2 is equal to if the contactor is 400 volt, that means A2 is equal to line 2. I made a mistake here. That means here A2 is equal to what? A neutral. Honestly, if the contactor is 230, A2 is equal to a neutral. If the contactor is 400, A2 is equal to what? Line 2. Do you understand that? Yes. So now our circuit now is complete. It's direct online. Then I want to also explain the connection of the motor here. Remember, here we're going to connect our motor in star, not in delta. In a star, and then this one you just take it on it. Let me come with another one that side. Let me draw on this. If you don't see a dust, the main way to click it. Alright? Done it. You see? Okay. In star, if you remember the star connection. Star connection. Okay, if you check the star connection, it's like this. Those are the windings. You see? Then you can name it the way you want to name. In consecutive, something you used to say VW1.